So this is the Google Sheet that I initially built to manually calculate how to figure out the start times. Sorry, the start times to finish at the same time. And like I mentioned, it's a little bit harder because I have two Teslas and there's two high power wall connectors and they're in a load sharing configuration, which means that the amps that go to the charger, they're dynamically shared between the two vehicles. So it's a Model X and a Model 3. So at 50 amps, uh, which is what the breaker's at, I think the circuit, the actual load, the actual power is less than, it's like 80% of 50. So it translates to 25 an hour, 25 miles an hour charging if it has the full 50 watts to the Model 3 and the 37 miles an hour to Model 3 if it has the full 50 watts to use for that. Now, if it were both charging at the same time, then you get half for each. But then if one finishes earlier, then the other one speeds up. So you can see how the calculation is a little bit more complicated. So first of all, I had to make sure that I had the charging speed correct so I can do the calculations for time. And then, if you look at the max range, so what's interesting is there's the car has a stated range, right? So when you buy a brand, at the time I bought the Model X, the range was 295. So as of now, Tesla, at least the software thinks it's not 295, it's 284. The Model 3, the stated range when you buy is 310, and the software thinks it's 310. So, and it's interesting, it actually fluctuates day to day, so that's why I think it's not an exact science, or at least maybe the BMS, the battery management system, maybe it does fluctuate based on what's going on in the chemistry. I don't know. But I, instead of having it being fixed, I think one of the things I'll track is what it thinks the range is. So perhaps that's an indication of degradation. But I'd rather base the charging percentages based on what it thinks the maximum is, which it does. So it would be more accurate because I always had this number fixed at one point. If it dropped or it started to decrease, it would skew the accuracy of some of the charging calculations. So that's the max range and how I get that from the vehicle. And then these two are one of the main two inputs. So it's its current state of charge. So what is its current range? So when I run this script roughly around 10 o'clock, like I said, usually it's parked in the garage well before then, and then I plug it in. So it needs to know where is it currently at. So that's the current state of charge. So real time, it figures that out, and then it timestamps it. So I know when the last reading was taken. So that way, if it didn't run or if there's a problem, I would know about it. And then the finish time, this is, I set to do the calculation. This is ideally when I want the car to stop, to finish the charging, to reach whatever state I want it to be, whatever 70%, 80%, 90%, I want to reach that state at 6 a.m. And so how this works is I have what's called a time of use plan. PG&E in the Bay Area, PG&E Pacific Gas and Electric, they have a time of use thing for electric vehicles, which is 11 p.m. to 7 a.m. On weekdays. So during that period, the electricity is the cheapest because no one's using it as much. So that time of use plan, that's when it's best to charge the vehicles because I'll get the cheapest rates to do that. Now initially I had this set up to finish at 7 a.m., which was when the latest I should charge it because that's the cheapest time. And I leave shortly after 7 a.m. in the morning anyway, so that kind of works out. But I found that because my house is old or people in the house are getting up at 6 or 6:30, they start turning on stuff and it starts to mess with the charge rate. It slows down sometimes. So I've noticed that when I woke up in the morning, and it bleeds over 7 a.m. So to give myself a bit of a buffer, I set it to 6 a.m. just to give myself that little bit of buffer. And it generally finishes, either right at 6 or a few minutes after 6. And then also the API and the Google application script, it has some quirks here and there. So sometimes it doesn't work as expected. So having this little buffer, it helps, I'll talk about a little bit more about it later, but it helps. So if I happen to miss it or something happened, I'll at least get an hour charge in. I can still make it to work, right? So it's kind of good to have a little bit of buffer, at least the way this currently works. And then obviously the charge level, it reads this from the car. So whatever it's set at, so in my case, I generally set to 70%, it will take it will calculate it and say, okay, well, if you set it at 70%, whatever is in the car, it writes it in here, and then it calculates, well, that means, and you can see the formula here, and this is why I thought the Google Sheets was preferable to use than a database, because if I want to change the calculation or whatever, it's easier to do here. And you can see that it's taking what it thinks the maximum range is, and then multiplying it by what the setting is in the car, which you can do in the app, and it puts that it estimates that it will land at this many miles when it's done charging. So essentially, this is telling it this will be the charge state at the end of the day, and when it finishes, and then this does the difference to figure out like, well, how how many miles does it have to put into the car? How much charge it has to put into the car to get it to whatever percentage you set it at, right? So it figures that out. And there's a little bit of an if formula so that it accounts for the fact that if the current level, the range is higher than what you set at, meaning that you set it lower, that you're not going to charge it or use it, it'll just make it zero. It's just a kind of a calculation thing. And then so I also do this calculation because at some point both cars will be charging at the same time. And so if they're both charging at the same time, then it'll be half the rate. So I need to know how long it'll take to charge it at half the rate. So one car will get to charge at full rate for a period of time, and then the other one will kick in, and they'll both be at half rate all the way till the very end when it finishes close to 6 a.m. So I need to account for that in the calculation. So this is what it would be at if both of them were at half rate. So and it also reverse calculates based on time that says, okay, if you started both of these at half the rate, here's when you would have to start to finish at 6 a.m. And that's the calculation it does here using the time here. And then what it does then is then for both these, it figures out, okay, so whichever one needs the longest amount of, or excuse me, whichever one needs the shortest amount of time to charge, that will be the one that charges later, right? So in this case, it'll say, okay, well, I'm going to charge in this case, it says Model 3, it has 59 miles to charge. It only needs 3.5 hours at half rate. So it can go later, whereas the Model X, if you charge it at half rate, it needs almost 7 hours. So what it's going to do is set it so that the Model 3 starts 3.5 hours or 3.2 hours later, and then it'll recalculate the beginning part of this 6.8 hours to charge at full rate to figure out what the actual start time is. So it figures out, okay, so at half rate, I'm going to get about 40 miles of this 85 miles I got to charge, and then the remaining amount of the 46 to get it to the full 85. There's some rounding errors here. A rounding decimals is probably 39 point something, but to get the other remaining 46 miles in at full rate, it's gonna that's what's going to be left with to go at full rate. So it recalculates it. So instead of starting at 11 p.m. or 11:12 p.m., it starts at 1 a.m. So 1 a.m. they'll start charging a full rate, and then when it gets to 2:50, which is when the Model 3 kicks in, it'll get halved, and then you'll have 40 miles left to go at half rate. So that's how that's how it figures it out. That was the sheet that covered the smart charging calculation. Now I want to talk a little about where I collect the telemetry or some of the data that the car produces. Share a little bit about that. So using an example, the Model 3 one. So you can see here that I collect the odometer information at the end of every day. So these are the dates, obviously, and the odometer readings each of those days. It calculates which day of the week that is. That's for the chart purposes, so I can know on any given day of the week what's the average. So that's the purpose of having this column here, and then calculate that based on the date. So again, a lot of advantages doing this in a Google Sheet versus a database. And then the mileage, obviously the daily miles, it does diff, between the previous odometer reading and today's odometer reading. I have this run at midnight every night. And so again, I think if you drive, irregular hours, or you don't have a consistent schedule, it's going to be, I think the mileage calculation may not always work for you. But you need to at least take it at the same time every day to have a 24-hour cycle. So I do it at midnight every day. It runs on a trigger, so I don't have to be awake for that. And then I have these additional formulas that calculate the weekly average, the days in service. So from the day I bought it, it can calculate how many days it's been out in the road, which allows me to do some calculation in terms of what my annual estimated mileage would be. And then this one is the range that it starts with every day. So essentially, it's this is what the formula changed actually halfway through. You can see this is, again, why it was really useful to have this on a spreadsheet. At first I was using a fixed number, and then I just used what the computer actually thought the maximum range would be at 70%. So this is what it charges to each day. That I not every day, but for that particular day, what it charges to, so I'll know the correct calculation in terms of how much difference I did. So if I started with 219 miles and I ended up with 153, how much range did I use? And I compare it to the odometer reading, and that's what kind of gives me an indication of efficiency. The car has the efficiency information built in. You can see that in the trip information in the console of the car. But I wasn't able to access that. That's not available in the API. But also I noticed there's a bit of a difference in the calculation. I wonder if that's because the way the car calculates it, that's based on the usage as a function of mileage, and this is more of an overall efficiency because it takes into account if you use it to power Sentry mode or run the air conditioner or the heater. So I wonder if that factors in more. I'd have to think that Tesla probably did factor that in, but there is a bit of a difference. But I thought this was a pretty foolproof way to say, like, well, if you drove 50 miles according to the odometer and you used 50 miles of range, then you were essentially 100% efficient to whatever the car, is rated at, right? So if it says like, hey, you're supposed to get X number of, miles for every watt hour you used, well, then, being at 100% means I used the correct one. Now I could be over sometimes, but I'm more efficient than what was rated, which is possible. But you could see it's kind of an interesting calculation to see. And there's some correlation, I think, on the hotter days. It seems that the efficiency is a little bit less, probably because I run the air conditioning more. And then this is the watt hour per mile calculation. I use this to compare to what's in the car, but I can't get this. I can't seem to find this data in the API. So it's in the car, but not available in the API. The capacity is an interesting one. This I calculate based on, basically, and I'll show this in the script, but it basically taking the current range and the current percentage it thinks it is, and I divide that, and that tells you what the maximum range it thinks it would have, theoretically. And then I do that to calculate the degradation. So what Tesla tells you when you bought the vehicle, for example, Model 3 is 310 miles. And then if it thinks it's 312, then it gives you a percentage of that. So in this case, it's somehow gone up. This could be because of the software update. I thought at some point they updated the software, but you can see that it's not a wild variation, but it varies a couple percent here and there. So it's not an exact number, which is kind of interesting. And then I also track the inside and outside temperature. I'm not sure if it really is an interesting figure or not, but I figure it's a good comparison against some of the energy usage. So this is how I track the telemetry. There's obviously more data you can track, but this is what I use. And then I create charts from it, right? So it gives you sort of what the mileage is, and you can see here some of it's interesting. So there's this pattern that shows, in the Model 3, I drive it more over the weekday. You can see it's a higher hump. This is why the Monday through Friday calculation was important, to know which day of the week it was. And you can see that it has this sort of convex sort of shape that I drive it more during the weekday than the weekend because that's largely what I use it for. And then the SUV, the Model X, I use it more on the weekend, or we use it. The family uses it more on the weekend because we go on trips with the entire family and whatever. So it has this more convex shape. So that makes sense. And then you can see here the mileage the estimated mileage doesn't vary a lot. Because it's an annual amount. The battery degradation, you can see it, was talking about earlier. It's not a wild swing. It's within a couple percentage, but you can see it's not terribly smooth either. So that's some interesting data there as well. So that's sort of largely, and this is again why I thought the use of the Google Sheet was so much more convenient to store the data in here for, if I wanted to add an extra column and add additional calculations or, add additional charts, so much easier to do it in a Google Sheet.